We're Essentia Health. We are in the business of streamlining and automating processes, and we have even automated the production of new software. Usually, we talk about the state of healthcare and health insurance in the United States, and today is a little different. Today, we are going to discuss how to build the electronic medical record system that will make this whole thing work, why it is better, and how it benefits the practice, the practitioner, and the patient. I'll be back after the presentation to discuss our conclusions and what this all means to you.
Last week, we discussed the functionality of our electronic medical records system, and this week, we are going to discuss how it works. This may wax a little bit technical, but it will be completely worth it to understand how this electronic medical records systems, EMR, is different and better than its competitors. The very first thing we are going to discuss is the code generation tool. This enforces the herding of the cats that are developers into doing everything in a uniform and sustainable way, doing it for them. This is something I've not seen other companies doing, though I have no idea why not. While it does put some pressure on a senior developer or two, it is absolutely essential. It ensures, as stated previously, that all the code is uniform. And it also does half or more of the work for the developer, putting us weeks, months, or years down the road on the first day of development. This tool relies on a solid understanding of the business processes and that a database is built that supports those processes. All of the things detailed in this paper are mostly generated by this tool, with the exception of the database structure, schema, itself. Architecture is the detail of what code runs, where it runs, and why it was put there. This is critical for larger applications like this, so we can separate concerns between user interface, UI, business logic layer, BLL, repository layer, and database. Generally, we don't want any logic, besides data validation, in the UI or the database. You do want business logic in the business logic layer, along with transformation logic, making your application database agnostic. Let's take a look at what these layers do and how they are written. This is not generated by the generation tool. This is as much art as science. This is what we see and interact with. For all intents and purposes, it is the application, though this is like calling the paint and curtains the house. Under the current paradigm, this is all designed and built in Microsoft's Blazor technology. Blazor uses a technique called WebAssembly, WASM, to replace the functionality of JavaScript and run real, type-safe, modern, compiled object-oriented code in the browser. I'm not sure why, but basically nobody is using the superior development technique that largely replaces ancient, slow JavaScript. Currently, the only people I can find using WASM are Figma, Lichess, Unity, and Google Earth. The one you have heard of is actually a beta version. We aren't going to discuss UI design, as that is more art than science. Suffice it to say that most of our development will be functional. The API layer consists of the 4 projects listed below. All are written in C#, currently in the latest version, .NET 8. This is where the controllers that actually contain the methods the UI calls are kept. It is basically a broker for the other 3 projects in this layer. The BLL is where a lot of the fun happens. Mostly it is used as an isolation layer between the database and the UI so that a database can be swapped out and code written to translate from the old schema to the new without changing anything else. For example, if your old database had gender column and your new database has a sex column, you could translate those values here. Additionally, real business logic goes here. If you need to check to see if a patient is over 50 before you schedule this colonoscopy, you do that here. Now, the way we have things set up, we use a rules engine, where we pass in the age and the policy, and the engine returns a true or false. That check is initiated here. More on the rules engine later. This is where all things database, except the database oddly, reside. All the procedural code that is not set-based or database code to access the database resides. We use a third-party package, Dapper, to make database calls and return data. Years ago, we had our own homegrown object relational mapper, ORM, and the world caught up to us and surpassed us. The surpassing is manifest in the form of Dapper. Most of the code we write, therefore, is to package and automate Dapper. This is where we keep all the data transfer objects, DTOs, an application programming interface, API, models that we create from the DTOs. We do that in the business logic layer as detailed above. Also, we include all the interfaces. These are contracts for things that can't change. It would be embarrassing if we had a client using our code that then changed and broke their application. So, interfaces. All the relational databases are in SQL Server, currently in version 2022. All of the data is encrypted at rest, meaning that a hacker can't steal a file and get anything useful. The tables themselves are locked to anyone who doesn't have administrative access, and all access to the data is handled in stored procedures. Since we have an abstraction layer in the stored procedures, we can enforce our security and multi-tenancy protocol there. When a user, doctor, or patient logs in, they are issued a globally unique identifier, GUID, that identifies them and their session. This GUID is stored in a JavaScript Web Token, JWT, and must be presented to pass every layer, including the database. The GUID is compared against the single sign-on, SSO, more on that later, database users table, and passed around to the other databases for maximum security. The GUID must be matched to return any data at all. This is unique in the industry, and this design appears nowhere else. Multi-tenancy means we keep everyone's data in the same database. The GUID detailed previously is also the basis for this multi-tenancy. The GUID identifies the user, and the user is associated with a practice or hospital, and by default can only see patients at those associated practices or hospitals. This has many benefits. No local, $300 million installations. One pool of patients with one record each, searchable. One installation means one maintenance team, and it isn't at the practice or hospital level. It is on our servers that we control, so you don't have to. One patient portal for all records. One repository of truth for all things medical. Reduced maintenance expense, and none at the practice or hospital level. There is a copy of all the tables in every database that the code generator produces that keeps changes to every record. All updates store the old record in this schema. All deletions are kept here as well. We can see who changed it when it was changed and again, what the old data was. Let's talk about the actual applications you will be using to document your patient encounters, run your practice or hospital, and keep your patients as healthy as they can possibly be. This is our insurance verification tool that returns deductibles, copays, and coinsurance from any of several clearinghouses. This tool is inherent in the insurance verification UI and adds up all the various costs and present the patient with an accurate estimate of the total cost and the patient responsibility. This is unique in the market. This is a database of terms and values that we get from various sources and translate into our standard. Librarian is a repository in Elk Stack that stores documents and makes them internally searchable. You can attach these documents to a patient encounter. We don't use the word chart. We need a clean break from the old paradigm, or the patient's medical record. Elk Stack has extensions that make the contents of these documents searchable. This is where we would keep scans of hard copies or facsimiles from lesser systems or practices. This is the repository of all things enterprise. This has the lists of practices and hospitals, all the various persons associated with them, insurance, addresses, phone numbers, and the like that aren't associated with any other specific application. This is the repository of the medical records management system based on the UMLS, as discussed previously. This is adequate for documenting any patient encounter, anywhere, at any time, in any of several languages. To this, we add a survey that allows the practice to modify the EMR to ask for specific information that they deem necessary. This is all designed and maintained by them. We just provide the functionality. Think of it like a medical SurveyMonkey. One of our ASCs uses this between surgery and recovery to record checks on the patient's blood oxygen, pressure, heart rate, etc. Further, this is the repository of all things patient education. The health risk assessment is simply a patient encounter. We can run lab results through our health and wellness platform and automatically prescribe either homegrown patient education or documentation from our partner CRAMS. It is all automatic, and we can tell when the patient has read and followed the education, as evidenced by more favorable lab results, entitling the patient to discounts on health insurance. This is all detailed in previous articles. This is the application that allows the user to pull various information from the databases and put it in a text message or email that is sent automatically. These are completely customizable by the hospital or practice staff. This is an enterprise resource management, ERP, style system that tracks and codifies every piece of equipment, every person, every building, capital assets, inventory, and process into one cohesive whole. This is designed, but has yet to be built. There are only so many of us. This functionality is the one-stop shop for reports. This is what shows and prints the estimate of patient responsibility, the singular and aggregate survey that we will discuss later, and showing the various surveys the patient fills out like pre-visit paperwork and satisfaction surveys. More on the survey tool later. This is the repository of all appointments. With it, we can associate any number of staff, any patient, any equipment necessary, and of course a venue. This, like everything we do, was designed to solve the general problem. And the problem we picked was Whitesnake in concert at Reunion Arena in 1987. That means we have a stage with the band on it, all their equipment, the venue itself, ancillary staff like bouncers and custodians, sub-venues or seats, and all the people to sit in those seats. All this is modeled with this tool, making it a breeze for you to schedule appointments. This is the holder of all things authorization and authentication. This is what is used to log in the user, issue the GUID we discussed earlier, and allow them to see various application and aspects of those applications through both individual and group rights. The schema for the database is shown in an upcoming section. This application details the various surveys a practice or hospital might need. These include the individual and aggregate patient satisfaction, pre-check-in, attachments of the EMR as discussed previously, and anything else the practice or hospital wants to use them for. These are available over the internet and can be assigned to the patient or doctor by staff. They are completely managed by the practice and can be configured any way the practice deems necessary. Pre-auth also is completely configurable by the practice or hospital and can be used to automate pre-auth websites. The user opens the pre-auth tool and it shows a browser where the user can navigate to any of the various pre-auth sites. The user can then go into administration mode and pick the input they want and associate with various information in the database, like they did with messaging. Once they have all the inputs recorded, the system remembers and fills those out for every visit to the page. While this is fairly rudimentary, it is the best we could do while the payers are attempting to make this impossible to automate. We do have a sample application started that shows this. We keep all our logging in one place: Elk Stack, Elasticsearch, Logstash, and Kibana. This makes it easy to search and find log entries and figure out what caused a problem for troubleshooting. This is a way to make our system less vulnerable to changes in logic. For example, let's say that we decide, together of course, that the age to start colonoscopies is 45 years old. We can type, in text, or the practice or hospital can, age greater than or equal to 45 and have it evaluated as true or false. If the engine returns true, it is covered. If not, it isn't. The genius part of this is that it is all text and evaluated at runtime, on the fly, not hard-coded and requiring a developer and a deployment to change. This also allows us to have different rules for different payers. Let's take a look at the way these things are actually coded. Databases are broken into entities that describe things or processes in the real world. They are joined together by relationships that fall into one-to-one, one-to-many, or many-to-many categories. Here is the schema for the SSO database as a representation of how we do things. Here we see the design for the various APIs as detailed above. Here is the BF, a broker layer that acts as an intermediary between the UI and the various APIs it needs to work. As discussed previously, the UI is as much art as science. This slide shows the various components needed to make this work. This UI layer connects to the BFF that connects to the various APIs that connect the database to accomplish the task at hand. In the next slide, we will show this as a comprehensive whole. There is a lot to unpack here, so you may want to pause and study this image. Here we show the application-specific architecture and how it all fits together and transfers information. Normally, we would talk about how we are saving healthcare with patient education and lowering premiums by over 50% and saving an additional 25% with improvements in health as a population. Today, though, is a little different. We have taken a deep dive into the architecture and functionality of our solution to this endemic problem and shown not only a path, but the execution to saving healthcare.
In previous articles, we have shown a way to save 50% now and an additional 25% eventually of the cost of health insurance using our own EMR. This is that EMR. This is the sine qua non for our new plan. We welcome your feedback in our efforts at continuous improvement. We have shown a way to make patients healthier by educating them on the consequences of their behavior, and a way to capitalize on that to the sum of $1.2 trillion, or about 25%. If we add that to the process automation savings of our solution, we are in the ballpark of more than 75% savings in total. We already have the best doctors and the best equipment. We just need to implement the above detailed framework to give them all the tools necessary for success. We have this system in prototype now, fully functioning. Contact us here or on our site, and we will be happy to provide a demonstration of the fully functional prototype. If you liked what you heard, please like and subscribe, click on the notification icon, subscribe to our newsletter, and follow us on all our social media and blog sites. You can read the text version of this presentation at senchahealth.substack.com or senchahealth.com. We have built a comprehensive health information system to keep the patient healthy and on the right track with the ability to incentivize healthy living. Implementing this system should be fairly simple and will completely revolutionize the way healthcare is paid for, saving countless lives. We have shown a way to use this system to make the best healthcare system in the world, also the most efficacious and the most affordable.